a quantum computer is a device which is built out of qubits. So remember, a qubit, an example would be an electron, which has this property that when you make an observation of the spin, let's say, of this electron, it behaves like a coin. It can be up or down, heads or tails, however you want to describe it. But that thing can also exist in a superposition, a combination of these things, and it's a perfectly valid configuration. And you use that. That's the kind of property that you use in building a quantum computer. You can also then ask the question, well, what happens if I get another one, two electrons together? These can be in what's called an entangled state. So then you have a much richer structure of this physical system. So an example of an entangled state, a very famous thing called a Bell state, would be where you set these things up. So the system of these two qubits, let's say they're up and down, these spins, right? So I can have the state up, down, plus, down, up, like that. A complete description of this state. Up, down, plus, down, up. What does that mean? So let's say I take one of these electrons and I separate them. It's a very famous paper written by Einstein, Podolsky and Rosen that first considered this in the 1930s, and they get very upset by the behavior. So we've got a system, a state, and it's up, down, plus, down, up, let's say. And I separate these electrons. I take one to, let's say, to Pluto, and leave one on planet Earth, right? And then, so what's the description of this thing in that state? Well, it's got, in the way I described it, there's a 50-50 chance that when I make a measurement of this electron, the up or downness of it, then there's a 50-50 chance it'll be either up or down. And the same for the other one. That's what that state means. But if it's up, down, plus, down, up, then it means that if I make a measurement of that one, if I say, well, okay, I know what that is, it's up. The other one has to be down. Up, down, or down, up. It can't be up as well. Same for the other one. If I go to Pluto and have a look at this one and it's down, then this one definitely is up, right? So this is called quantum entanglement. And the reason it bothered Einstein and others is it would appear that something is instantaneously changing. And it's not just your knowledge of the system that's instantaneously changing. It would seem that the system itself is instantly configuring itself when you make